Hey guys, this is Taylor here, and today we are solving the problem number 3638, which is maximum balance shipments. So let's read the problem. So you are given an integer array weight of length n, representing the weight of n parcels. Okay. Now they are arranged in a straight line. Shipment is defined as a contiguous sub-array of parcel. Shipment is considered balanced if the weight of the last parcel is strictly less. Last parcel, okay, weight of the last parcel is strictly less than the maximum weight among all parcels in the shipment. Select a set of non-overlapping contiguous balance shipments such that each parcel appears in at most one shipment. Parcel may remain unshipped. Okay. Return the maximum possible numbers of balance shipment that can be found. Okay, let's understand the problem. Okay, so my test case is here. In this array, I need to find sub arrays. Okay, contiguous sub-arrays I need to find. In that contiguous sub-array, what is the condition I need to follow? So there is only one condition that I need to follow. So whatever the last parcel, okay, if let's say this is my sub-array, so whatever the last element, this three, it should be less than all of the elements. So all of the elements, so what is the maximum? Maximum is 5. So this 3 should be less than 5. This is the only condition that I need my server is to satisfy. And how I will be calculating the answer? So I need to find the maximum server is okay. So the like best answer, like it will not be possible, but how many subarrays, maximum subarrays I can have in max? So I think this all individual elements are single subarrays. So max answer can be range from 5, but this 5 should set this subarray should satisfy this problem, this I think condition. So let's try and see how we are able to satisfying this condition. So if I let's say start from here, I will start from here. I will, my maxi is, let's say, initially 0. I will update it to, okay. Now I will go here. I will check whether this is maximum than this. Yes, it is. So let me update it. Okay. Now I will go here. Whether this number is greater than this. No, it is not. Then my maxi will remain same. But is this less than maxi? Yes, it is less than maxi. Can I say that this is my one subarray? Yes, I can say this. Okay. Next time I will start from here. Now I like as soon as I count one, my count increased here, right? It was 0, it increased to 1. As soon as I increase my count, I will reset my maxi to 0 again. Okay. Now in this part, I am here. My maxi will become 4. Is this 4 less than 4? No. Is this 4 less than maxi? No, it is not. Okay, let me increase now. Is this 3 greater than 4? So maxi won't be updated. No. Okay. Now I need to check the second thing. First thing, like update maxi. Okay. Update maxi if you can. Second thing is check to increase count, and to increase count to for this thing, what I need to do, I need to just follow this condition. That's it. So as soon as I reached here, I checked 3 is less than 4. 3 is the less element among the all largest elements. So I can increase my counter here and I can point out here. Let's bring down one more test case quickly. So here is my test case. Okay, and let me add commas. Okay, so I will start from here. My maxi will be 0, my count will be 0, and I am good to go. Okay. Uh, Let me update maxi. This is first element. Okay. Now I need to check, is this one like I have updated, so ideally it should not be the case. Now I will check. Is this greater than maxi? Yes, it is. Let me update it. Okay, I will go here. Is this greater than maxi? Yes, it is. Let me update maxi. I will check. Is it greater than maxi? No, it is not. No, it is not. Yes. What I can do? I can have one subarray. Yes, I can have. Yes. Okay. Let me take. So this is my one subarray. Let me increase my count. Now I am here. Now my I will reset my maxi. Okay. Okay. Super. Now is this greater than maxi? Yes, it is. Let me update. Is this greater than maxi? Yes, it is. Let me update. Is this greater? Yes. Is this greater? Yes. Is this greater? Yes, it is. Okay. Now, I will reach here. I will reach here. Is it greater than maxi? No, it is not. So, can I have one subarray? Yes, yes, I can have. Let me increase the count. So this way I can have only possibly two subarrays. So if you see, we are increasing, 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 then the shorter element that we got. So I hope this question is clear to you. It's simpler than the first problem of the contest. So let's write pseudocode for it, then we'll write like actual code. So pseudocode is very simple. So I will write my maxi as 0 and count equal to 0. Now I will go from for I equal to 0 to n minus 1. I'll check if nums of I is greater than maxi, then just update maxi equal to nums of I. So else I can write something like this. If nums of I is greater than maxi, why I'm writing this condition? It should be less, it should be less. So why I'm writing this condition? So let's say if my array is something like this, 4 comma 4, my maxi would was 4, right? Maxi was 4. And like maxi can't be updated due to this, right? So I will get I will come here. Now this 4 is equal to 4, but I need strictly greater, right? Strictly greater. That's why I'm writing this condition. So if my maxi is strictly greater than the current number, then only I will update. So my counter will become plus equal to 1 and maxi will become 0. And in the last, I can definitely return my counter. Okay, you can do one more thing. If you write equal to here, then you can directly assign things here. So either would work, not a problem. Okay, let's quickly write the code for it. Length of wait, counter will be 0, maxi will be 0. For I in range from 0 to n, what I need to do if weight of I is greater than maxi, then let's update maxi. Otherwise, I need to check if weight of I is strictly less than maxi, then I can increase my counter as 1 and maxi can be set as 0. And in the last, I can return the count. I think we are good to go. Let's try to run this. Okay, it's working fine. I have written some custom test case as well. It is working fine. Let's try to submit this. So yeah, it is submitted. I hope you are able to understand this simple problem. So in the topics in the hints, we can see that they are telling to use stacks, they are telling to use DB. But why to make problem that much unnecessary complex? If we can solve it easily via some simulation, via some observations, and I don't think we need a DB or stack here. So I hope you guys understood this problem and if you like the video, please make sure you subscribe and give a thumbs up. That will motivate me. And thank you very much for watching this video. Thank you guys.